All right, everybody, let's look at the 11.3 worksheet about the volume of pyramids and cones. This is one of my favorite sections. I don't really know why. I just like it. So 13, Jacob is finding the volume of the cylinder. What is his error? Well, when he was finding the volume of the cylinder, he accidentally used pi squared instead of r squared. And then he also used 2 as the height instead of 3. So 2 mistakes. He used pi squared instead of r squared and used 2 as the height. So that's one big thing. Number 14, how would you find the volume of a right square pyramid with a base length of 10 centimeters and the altitude of a triangular side is 13 centimeters? So that's a little interesting because that's a shape we don't use very much. We don't use the altitude of a triangular side very often, but we can. We call that the slant height. So we would need to use the slant height and use that to find the height of the actual pyramid. So we would first use the Pythagorean theorem with that slant height of 13 and that base side, or half of that base side of 10. So first, use the Pythagorean theorem. The Pythagorean theorem with the slant height, and half the base. To find the height of the shape. The height of the shape. Then calculate volume. Then calculate volume. All right. Number 15, in terms of radius r, what is the volume of a cone whose height is equal to its radius? Well, we can just use the formula for volume. We can say 1/3 the area of the base, pi r squared, times the height, but the height is also r. So that just gives us 1/3 times pi times r cubed, because r squared times r is r cubed. And that's it. Number 18, we're finding the volume of both of these. So for 18, where'd we go here? There we go. So for 18, we'll take 1/3 the area of the base, pi, times 6 squared, times 9. And we will say, well, that's going to be 339.3, roughly. And then for 19, we've got another 1/3 the area of the base, which is 4 times 4, or 4 squared, times the height of 10, and that's 53.3 units. Come back up here to 22. A cone is inscribed in a right square pyramid. What is the remaining volume if the cone is removed? Let's do the volume of the pyramid minus the volume of the cone. So the volume of the pyramid would be 1/3 times the area of the base, 18 squared, because it's a square, times the height of 12, minus the volume of the cone, which is 1/3 the area of the base, pi, times the radius of 9 squared, times the height of 12. So the first part is going to give us 1,296, that's the volume of the pyramid, minus the volume of the cone is 1,017.87. And if we subtract those, we should get 278.1, which is the remaining volume of the shape. There we go. Number 23, find the volume of this composite figure. We've got two pieces. We've got a cylinder and a cone on top. So the volume of the cylinder will be pi r squared, pi times 1 squared, times the height of 5, plus the volume of the cone, which is 1/3 the area of the base, pi times the radius of 1 squared, times the height of 2. So that'll give us 5 pi plus 2/3 pi. And then if we put that just in a decimal approximation, that'll be 17.8 units, or of course 5 2/3 pi units cubed. Number 24, we've got a rectangular prism and we've got a pyramid. So that rectangular prism has a volume of 5 times 10 times 10. The pyramid has a volume of 1/3 the base, 10 times 10, times the height of 18. So we end up with 500 plus 600, giving us a volume of 1,100 units cubed. Let's keep going. Number 25. This one's always fun. Shang makes gift boxes in the shape of a right square pyramid. She fills each box with chocolate cubes with 7 8-inch sides. She can fill about 75% of a box. How many pieces can she fit in each box? So first, let's find the volume of the pyramid. The volume of that box is going to be 1/3 area of the base, 4 squared, times height, 4.5. So that's going to give us 24 inches cubed. But she can only fill 75% of that volume with chocolate. So we'll take 24 and multiply it by 0.75 to find that 75% of that box is 18 inches cubed that gets filled. So let's find the volume of one piece of chocolate. That would be a cube with 7 8-inch sides, so 7/8 cubed is going to give us roughly 0.67 inches cubed per piece of chocolate. And now it's just a matter of taking our volume of 18, dividing it by the volume of 1 cube of chocolate, 0.67. We find that 26.9 pieces will fit. But since that's not quite 27, we have to round down and say 26 pieces is the number that fits in the box. Number 27. The basin beneath a fountain is a right cone that is 7 meters across, that's the diameter, and 1 meter deep at the center. After the fountain is cleaned, the pool is refilled at a rate of 300 liters per minute. 1 cubic meter is 1,000 liters cubed. How long does it take to refill the pool? So we'll go ahead and we will find the volume of the pool first, which is a cone, so 1/3. Area of the base would be pi times the radius of 3.5 squared times the height of 1 meter. That's going to give us 12.86 meters cubed for the volume of the pool. Then we're going to take 12.86 meters cubed, multiply it by 1,000, because there's 1,000 liters, or 1,000 liters in 1 cubic meter. Find out that that's 12,860 liters of water. We'll take 12,860 liters divided by 300 liters per minute and get 42.9 minutes to refill the pool. All right, these ones, Cavalier's principle states that if two solids have the same base area and the same height at every cross section, then the two solids have the same volume. Just a definition there. And then number 30, what is the volume of the largest cone that will fit entirely within the right square prism? Well, the largest cone that's going to fit in here is going to be the cone that touches all 4 sides of this prism at their midpoint. So it's going to be like a, I don't know how to draw very well, but it's going to be a circle that is inscribed in here. So the base is going to look like this. It's going to touch all the sides, and it's going to come down from each side and make a cone shape. at the bottom of the shape, although, you know, the perspective is not going to work well for that. We'll just draw the top. And that cone is going to have a radius of 4 because that's half of the base. So all we need to do is 1/3, because it's a cone, times pi times 4 squared, times the height of the shape, which is the same as the height of the rectangle, which is 4. That gives us 64/3 pi, or letter C. That's all there is to it. Let me know if you've got any questions, and have a wonderful day.